Okay, this problem is going to be a little bit long and hairy. It's going to be a hairy one. But and that is because I just made up two functions and didn't really look at the math, and it's kind of like a real world thing, you know. It's going to be nasty, so a nasty math problem. But I guess I better get started. I've got some things labeled here. This is kind of for the business people. Consumer surplus, equilibrium point, producer surplus. We're not going to really get into any of that. I just wanted to kind of, label this stuff because this is what these two shaded regions kind of reminded me of. So I'm sure that I'll have other tutorials on my website where you can, oh, and by the way, that's at schoolwork101.com, where you can maybe find more about this kind of stuff. So anyhow, we're going to be finding the area of this blue shaded region or bluish green, and then this reddish color down here, reddish brown. I don't know. Can't think of the name of it. I better get started here. What we're going to need to do is find the area under the blue curve here. We're going to find that area, which is all the way to the x-axis, and then we're going to subtract off this piece here. And that difference is going to be what we get left with here, and of course I've actually got it written in here. It's approximately 1.219. And then we're going to want to find this area, and so that means that we're going to take this line here, and I think its y is equal to 2.44, and we're going to integrate up underneath this line, and then we're going to integrate up underneath this curve here, right? Take the big piece, subtract off the small piece, and what you get left with is, well, approximately 2.538. Let's get busy with the math. I think I'm going to find this one first. So here's our function of that the top line, and we're going to we're going to set both of these equal to each other, both these functions each equal to each other, and solve for x using the quadratic equation. Kind of got it listed here. The reason we're setting these both equal to each other is because we want to find this guy right here where these two lines intersect. As you see here, that's exactly what I do, is I use the quadratic equation, and this is what we end up with. Something nasty. I think I just plugged this into the calculator and approximated it, and I ended up getting 1.56. Don't worry about this one here. We end up getting a negative. We're not interested in that. So you want to take this number now and plug it back into either one of the functions, because what we're interested in is finding that y value. And of course, I do that. I plug it into the first function, and we get all this nice, lovely stuff. And we end up with, I end up approximating it, which is 2.44. So we set them both equal to each other. We ended up solving for x. We got 1.56. You want to plug that into either one of these functions, and you get the 2.44 out. Now I'm taking the integral. I'm finding the area under the curve here of that top line, and we're subtracting off the number that we just found here. Now I'm keeping this stuff in radical form. Anyway, so we get down to, let's see, I do this one first, it looks like. I'm going from 0 to this, plugging all this stuff in. We got a 0 here. Didn't want to leave that off. And I end up getting, it looks to me like approximately 5.027. I kind of give up on all the radical stuff. Let's just start approximating this, right? And now take the integral of that lower curve, or straight line that is, and we end up getting approximately 3.080. So we took the larger one, subtracted off the smaller one, and this is what we get. So that green area is 1.219. And so there it is. Now this is the area that we're going to find here. So we're going to take this function minus this one, and this is our setup. We end up getting for this 3.808. And of course, the bottom curve, we end up getting 1.270. We take their difference, and you get 2.5.